On your screen, you can see the function y equals the square root of x raised to the power 5 plus 2. We are going to find the derivative of this function using the chain rule. Just like in my last video in which I covered easier examples of the chain rule, we can make the distinction between the outside function and the inside function. The outside function is in green and the inside function is in blue. This will make applying the chain rule much easier. Let me show you. On your screen you can also see the general formula for the chain rule. It says that the derivative of y with respect to x equals the derivative of y with respect to u multiplied by the derivative of u with respect to x. We are first going to find the derivative of y with respect to u and the derivative of u with respect to x. We can split up the function on your screen in two functions. Y equals the square root of u and u equals x raised to the power 5 plus 2. Again, the outside function is in green and the inside function is in blue. The derivative of y with respect to u equals 0.5u raised to the power minus 0.5. We found this using the power rule. The square root of u is the same as u raised to the power 0.5. To find the derivative of this, we multiply u by the power of 0.5 and then reduce the power with 1, so it becomes minus 0.5. The derivative of u with respect to x equals 5x raised to the power 4. Again, we found this answer by using the power rule. We multiplied x with the power of 5 and then reduced the power with 1 to get 4. The derivative of 2 is 0, because the derivative of a constant is always 0. As you can see from the general function of the chain rule, we can find the derivative of y with respect to x using the two answers we have just found. The derivative of y with respect to x equals 0.5u raised to the power minus 0.5 multiplied by 5x raised to the power 4. We can now substitute x raised to the power 5 plus 2 for u. This gives us 0.5 multiplied by x raised to the power 5 plus 2 raised to the power minus 0.5 multiplied by 5x raised to the power 4. We can simplify this as 2.5x raised to the power 4 multiplied by x raised to the power 5 plus 2 raised to the power minus 0.5. This is the same as 2.5x raised to the power 4 divided by the square root of x raised to the power 5 plus 2. Next up, we have to find the derivative of y equals 4 divided by 2x raised to the power 2 plus 4x plus 4 raised to the power 6. Again, the outside function is in green and the inside function is in blue. As you probably already know, we can rewrite this as 4 multiplied by 2x raised to the power 2 plus 4x plus 4 raised to the power minus 6. We can split up the function on your screen in two functions. Y equals 4u raised to the power minus 6 and u equals 2x raised to the power 2 plus 4x plus 4. The derivative of y with respect to u is minus 24u raised to the power minus 7. We found this using the power rule. To find the derivative, we multiply 4u by the power of minus 6 and then reduce the power with 1, so it becomes minus 7. The derivative of u with respect to x equals 4x plus 4. Again, we found this answer by using the power rule. We multiply 2x with the power of 2 and then reduce the power with 1 to get 1. The derivative of 4x equals 4, because we multiply 4x with the power of 1 and then reduce the power with 1, so it becomes 0. As you can see from the general function of the chain rule, we can find the derivative of y with respect to x using the two answers we have just found. The derivative of y with respect to x equals minus 24u raised to the power minus 7 multiplied by 4x plus 4. We can now substitute 2x raised to the power 2 plus 4x plus 4 for u. This gives us minus 24 multiplied by 2x raised to the power 2 plus 4x plus 4 raised to the power minus 7 multiplied by 4x plus 4. We can rewrite this as minus 24 multiplied by 4x plus 4 divided by 2x raised to the power 2 plus 4x plus 4 raised to the power 7. Simplifying this gives us minus 96 multiplied by x plus 1 divided by 2x raised to the power 2 plus 4x plus 4 raised to the power 7. This is the final answer. We have found the derivative of our original function using the chain rule. That brings us to the end of the video. If this video was helpful to you, please support me by liking and subscribing to my channel. If you want to support me even more, check out the link in the description. My next video about finding the second derivative using the chain rule is now on your screen, so check it out if you want to learn even more.